Welcome viewers, we have another physics problem for those doing first year. It says the figure shows a traffic light of weight 1 times 10 to the power 2 newtons. Find the tension in each cable. So we've got tension 1, 2 and 3. So what are we going to apply in order to find the tension? First of all, take into consideration that you are just going to use vector resolution and you are able to find everything. So step 1, what you need to know here, all right, is that first of all, this traffic light which is here, it has got two things attached to it. First of all, the traffic light on its own, okay, it has got the weight, let's call it FG. It has got the weight. At the same time, it has got the tension T3. This just on the traffic light. Let me just do this. That is the traffic light. But when we combine everything, okay, when we combine everything on an X or Y plane, we end up getting something like this. So, all right, let me use white for this matter. So I will draw the X or Y plane. So that and that, like that. So this is my X and that is my Y. So at the same time, I'm just going to use another color. Okay, so we have this issue now. We have this force here. All right, so when you draw, even just here when you draw the X or Y plane, this angle and this angle, they are the same. So even this one is 53. This angle and this angle, they are the same. Even this one is 37. So we end up having the same thing here. So we have 53 here and we have 27, not 37, sorry. Okay. Then we have this weight here. Take note. We have the tension, this tension here. T3 is acting downwards. You can see it. It's acting what? Downwards. So this is our T2, our T1. So once you resolve it like that, but why are these angles being the same? Look, this is a Z property of angles. They are the same because they are opposite angles, so they are the same. So we have how many things that are we talking about here? We have the T1, the T2, the T3, this T3 which is acting downwards, and we also have the weight of the same of the same traffic light. So now let's do this. We'll do it the simple way. So in the X, okay, so let's say forces. We can say a force. Then we say X, all right, component. Then you have the Y component. Yeah. So the forces that we're dealing with is the tension 1, tension 2, and tension 3. So what about in the X-axis? What exactly do we mean? What I'm trying to mean here, ladies and gentlemen, just that in the X-axis, what are we dealing with? So we are going to resolve this. So we do this. Okay. Even there we do that. So we have T2Y, we also have got T2X. We've got T1Y and T1X. Now for T3, there's no in the X, we just have got T3Y because there is no in the X-axis. Is it making sense? Good. So we take everything in the X. So when you talk about in the X, for the X, we've got T1X and T2X. Eh? Good. So for T1, okay, in the X-axis, we have T1 cos 37. Remember that the X-axis was always associated with what? X-axis. But which angle are we going to get? We are going to get the angle all the way from here up to here. Now, I've already used 37, which I know it will be, negative. Why? Because cosine in the second quadrant here, it's negative. Are we there? It's negative. Another way you can know that it's negative, look at how the forces are going. So you have this, so it's going like this. And it means this, where the arrow is pointing, it's negative, so you add a negative here. Or if you don't want to use this, just say you get the angle from the positive X-axis. So You know that from here to here it's 180, right? So we say 180, so 180 minus 37, you get 143. So just put cos 143 if you are getting an angle from the positive x-axis. This same thing applies to T2. T2 is T2. Alright, so for T2, we're just getting up to there. So let me just get rid of this. For T2, just from there to there, that's the angle. That's all. So 53. Cos 53 what? Degrees. Do we have T3 in the x-axis? No, it's 0. We go to the y-axis. It's the same thing. Alright, to the y, T1 here is going up, so it's positive. So we are going to say, we are still maintaining the same angle. T1 cos 143. I said you get it from the positive x-axis. Then for T2, it is still going up, so that one still remains the same. Oh, not cos, sorry. Sine. So we have sine 53 degrees. But here, look at T3 is going what? It's pointing down. And since T3 is pointing down, okay, but what exactly is T3? T3 is just equal to the weight. This is why I said take note of this diagram here. So the T3 is just equal to the weight, but just in the opposite what direction? Newton's third law of motion. Do you remember? So these two are equal in magnitude, but just opposite in what? In direction. So we are going to say we put negative 1.00 times 10 to the power 2 Newton. For that one, we are okay. Then we find the sum in the x and the sum in the y. So let's go. So the sum of forces in the x. So what we have this and this plus 0. Now remember that the sum of forces should always give us what? 0. The resultant force should always be what? 0. So let's go. So we have this plus this one. Okay? So we have T1 cos 143 plus T2 cos 53. This should give us what? 0. Equation number 2 is the sum of forces in the y should also give us 0, which is equal to, in the y we have T1 sine 143 plus T2 sine 53. We have minus 1.0 times 10 to the power 2. This should give us what? 0. These are the equations that we have. And from here, we can actually make something the subject of the formula. Let's do this. Have you seen this from the first equation? We can make T1 or T2 the subject of the formula. Can we do that? Yes, we can. So we can say T1 is just equal to negative T2 cos 53 degrees over cos 143 degrees. If I make T1 the subject of the formula. This is the T1. Now I can use the second equation to replace where there's T1, I put it all this. Alright, so using the second equation, where there's T1, I'm just going to put that. So negative 2 cos 53 degrees. Just here where there's T1, I'll put that over cos 143. Then we say multiply by sine 143, okay, plus T2 sine 53 minus 1 times 10 to the power 2. This is equal to 0. Now let us work out this. So we have cos 53 divided by cos 143. I'm getting negative, but there's already a negative here, so that one will give us a positive. But this positive, let's just multiply with sine 143. So we say so 0.75, right? 0.75 you multiply by sine 143. I'm getting 0.45. So I'm getting 0.45 plus, what is the, oh, by the way, there's T2 here. We have this one sine 53, so sine 53, it's 0.79, something like that. Alright, so plus 0.798, I'll just round it off to that. Then we have We can take this one the other side, which will give us just 1.00 times 10 to the power 2. This is still T2. Then we can add these two. So say plus 0.45. So I'm getting like T2 is just 1.248. And this is equal to 1.00 times. But the physics is done. We're just doing the math now. The simultaneous equations. That's all. We cancel. So we get our T2 as. So we have 1.0 there. 2 by 1.248. So I end up getting something like 80.13 newtons. That is our T2. Now let us now find T1. We already made T1 the subject of the formula. So T2 has already been found. So we are saying T1 is equal to 80.13 multiplied by cos 53 over cos 143. By the way, there's a negative, so you need to put a negative cos 143. So let's go. Just say, so we have cos 53, then we say divide by cos 143, which I know is negative, then you just multiply by 80.13. So this one is giving me T1 is equal to 60.38 degrees. So you can see T2 has been found. But what of T3? T3 we already established something that it's equal to this one but just opposite in magnitude. So therefore we can now conclude. Oh, not degrees. What am I writing? Newton. We can now conclude and say T1 is 60.38 newtons. T2 is 80.13 newtons. And T3, which is just equal to the weight but in opposite direction. So negative 1.0 times 10 to the power 2 newtons. And there you are. So these are just application of Newton's laws of motion. And that means you need to have some knowledge on vector resolution. See you.